instrumentation and diagnostics that we use for material characterization. One of the baseline frontline apparatus that we have in fire science is the cone calorimeter. As the name would imply, this is a piece of equipment that's used for measuring energy output. Okay, so what we can do is we can take a 4-inch by 4-inch sample of a material, we put it into a sample holder, and we put it onto this load cell, and we subject it to an external heat flux, just being a resistive wire. This is much like how your toaster oven works. And we provide a sparker. So the heating coil is just this right here. It's a conical shaped resistive wire, which is where we get the name for the cone calorimeter. And so what we can do when we have an ignition is we'll measure soot production, CO2 production, we'll measure your mass loss rate, and most importantly, we're going to measure your oxygen concentration. So the basis of this calorimeter is what we call oxygen depletion calorimetry. So what we know is for every 1 gram of oxygen consumed, we produce 13.1 joules of energy. So independent of what material you're burning, we can tell the power output simply by measuring that O2 concentration. That will get us things like your average heat release rate or maybe your peak heat release rate, but we can also use it to determine bulk properties like your heat of combustion. For smaller scale experimentation like the TGA DSE, you might do homogeneous materials. Very common in the cone calorimeter, you do heterogeneous materials, especially very popular in the built environment. So we'll work very often with, for example, we have a client that's an architectural company, and they need to pass a standard. Let's say it's the ASM E84 tunnel test. We can start here at the cone calorimeter and get approximate values for their material and do some modeling for how they would perform in something like a 285, 286, or 84 test. This allows for rapid testing and rapid iterations as opposed to paying for a $10,000 ASTM test. So we use this tool in education. We use it for our IQPs and our MQPs, which are our undergraduate projects. We'll use it in master's or PhD thesis work, but we'll also use it in what we call service to industry, which is where we can have an industrial partner come in who just needs to do some material characterization. We can either just rent out the ASTM cone to them, or we can work with our faculty to help them understand material behaviors. In addition to the cone, behind you we have muffle furnaces. The smaller, grayer, darker gray box is a 1100 degree centigrade muffle furnace. Right now we're actually doing client testing on spontaneous heating. Next to that is just a small convective oven. That's very often what people like Giovanni or Javad will use for drying and conditioning their samples for pine needles and such. Behind you here, as I said before, we have a thermogravimetric analyzer and a differential scanning calorimeter. These are micro-scale apparatus where we can, again, use them for material characterization. Things like phase changes, so at what temperature do you transition from solids to liquids to gas, or we can look at endothermic and exothermic reactions. Then this piece of equipment here, and if you want to huddle around, this is where we're actually going to do our demo. This is the FPA, or the fire propagation apparatus. This was donated to us by FM Global, who is the originator, the manufacturer of the FPA. The FPA works similarly to the cone, where we would take a 4-inch, whether it's a 4-inch round or a 4-inch square material, and we'll subject it to an external heat flux. In the cone, we had a resistive wire. Here we have lamps, and they'll do the same thing. They're going to impose an external heat flux down onto your material. I believe for today you are going to use, you are going to see the lamps used. Yeah, so we're going to do a very, when these can go up to 100 kilowatts per meter squared, and at that intensity, you can't be within even 10, 20 feet of this. It's so bright. So we're going to do a demonstration today at a much lower level, just so you can see the functionality of the apparatus. One of the other differences between the FPA and the cone is that we can do environmental conditioning here. So we can go from environmental air at 20.9% oxygen, we can go all the way down to a purely nitrogen environment, or we can go to oxygen rich up to 40% O2. So with that, I'm going to hand it over to Nadia, and Nadia is going to do a demonstration burn. So if you'd like, everyone can get a bit closer than you are. It